So in this video, we're going to tackle section 1.2, real numbers and translating algebraic expressions. In my book, this is on page 18. So first thing we want to do is just, if you can, maybe pause the video and take a few moments to look at these definitions. I'm going to give you a quiz or a test where I'll write down a number and I'll say, which groups do this number belong? So for example, if I were to write the number on the side here, let's say number 3, and I were to say, where does this 3 belong? You might say, oh, 3 is a natural number, right? It's a whole number. 3 is also an integer. And believe it or not, 3 can be considered a rational number because 3 can be written as 3 over 1. And according to the definition for rational numbers, right, it's a real number that can be written in the form of a over b, right? So 3 over 1 is still equal to 3. So 3 would be considered a rational number as well, okay? Or maybe I'd give you a number like 3 over 4 and say, where does this belong? Well, it's not a natural number because there's no fractions in natural numbers. There's no fractions in whole numbers or integers. But 3 over 4 can be written as a over b, or 3 over 4. So 3 over 4 would be considered a rational number. And I forgot to mention, 3 is also a real number, and 3 over 4 would be considered a real number as well. Okay? So again, take a moment to just read through this definition. Maybe you want to pause the video for, 5 minutes and just look through these, and then we're going to do some practice problems. So I'm going to go to the next page. So on this next page, it says, write the sets of numbers to which each of the following numbers belong. And again, this would be a pretty good test question or a quiz question where I'll give you a couple of numbers and I'll ask you to tell me, are they natural numbers, real numbers, whole numbers, integers, and so on. So since negative 16 can be written as negative 4, right, because the square root of 16 is negative 4, I might say that this is a real number, right? This is also an integer. And what else can we say? We can also say that, oops, sorry about that. We can also say that negative 4 is a rational number, right? Because negative 4 can be written as negative 4 over 1 or 4 over negative 1. All of these equal negative 4, right? And remember, the definition of a rational number says it can be written, a real number that can be written as a over b. All right, so that's letter A. Let's take a look at letter B. So 1/5, this is going to be real, and it's also going to be rational. Okay. Number C, or letter C, this is irrational. Okay. Oops. Okay, because if I were to do the square root of 20 in my calculator, it's going to become a non-repeating decimal. And to prove that, I'll show you my calculator, right? The square root of 20, you'll see how I get 4.47213955. These numbers go on forever. So it's a decimal that's a non-repeating. So that would be considered irrational. Other numbers that would be irrational, something like the square root of 3 would be considered irrational, right? Or the square root of 5 would be irrational because these numbers, again, they go on forever, okay? Square root of 16 or square root of 25, oops, right? If I were to do the square root of 25, well, you see I get 5, right? So I could say that's a natural number, a whole number, an integer, a real number. But these other ones, 3, square root of 3, square root of 5, these are irrational numbers. They're still real numbers, but they're irrational. And again, I just want to remind you of our definition, right? Of rational numbers, irrational numbers. natural numbers, whole numbers, and so on, right? So you kind of want to practice this because I am going to ask this on a quiz or a test that's probably going to come up in a couple of weeks. All right, let's keep going. There are a few practice problems down here. The answers to these practice problems are in the back of your book. So, maybe try to answer these questions and see how you do, and check your answers in the back of the book. The next thing I want to discuss are number lines, right? So here's a basic number line with no values. I just want to mention that the negative numbers are to the left of 0, positive numbers are to the right of 0, and 0 is neither positive or negative. On the next page, they give you the steps to construct the number line, right? You're going to draw a horizontal line. My line's a little crooked. Choose a point on the line and label it 0. And then again, everything to the left of 0 is negative. Everything to the right of 0 is positive. And then it says choose a convenient length, right, or a unit. So do you want to count by ones? Do you want to count by fives? Do you want to count by a half? And then they give us an example, right? They say construct a real number line and label the location of the given numbers, right? So negative square root of 16 is the same as negative 4. So here's negative 4, negative 5, right? This would be negative 3, and so on. Then we have 1/2, so we know that's going to be in between 0 and 1, right? If this is 1 and this is 0, right? A half would be in between. Square root of 17. I'm not sure what the square root of 17 is. So if I were to use my calculator and enter square root of 17, I get 4.12. So it's going to be somewhere, right? If this tick mark is 4, right, and this is 3, and we have 5 here, square root of 17 would be in between 4 and 5, but closer to 4, right? And then 2.5, well, if this is 1 and we have 2 here, well, 2.5 is going to be in between 2 and 3, okay? Next, again, there's some practice exercises where they want you to construct the number line. So do these 3 problems and then check your answers in the back of the book. If you have questions, I'm going to have Zoom office hours so we can discuss, and I'd be happy to work with you through this. So I'm going to stop here and I'm going to continue with a second video. So after you've worked through these practice problems, look for my second video covering section 1.2. Thank you for watching.